Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study the frequency and time period of revolution of electron around the nucleus. So let us talk about frequency first. So I'm writing frequency. Frequency of revolution, more exactly. It can be defined as the number of revolutions made by electron around nucleus in 1 second. It can be defined as the number of revolutions made by electron around nucleus in 1 second. That stands for frequency. Now, that's my nucleus plus Ze. This is the nucleus. This is the orbit on which the electron will revolve around the nucleus. So, I'm writing in one revolution. Distance traveled by the electron will be the circumference of the orbit. So, in one revolution, distance traveled by electron will be the circumference of the orbit. So in one revolution, distance traveled by electron will be 2 pi r, because this is the circumference of any circle. Now let's talk about velocity of electron. I'm writing what will be the velocity of electron. It can be defined as the distance traveled by electron, in 1 second. So that is the velocity. So we have to evaluate the number of revolutions made by electron in 1 second. So that's the frequency. So frequency will be equal to then total distance traveled by the electron in 1 second, total distance traveled by electron in 1 second divided by distance traveled in one revolution. Distance traveled in one revolution. By this way, you will get the number of revolutions, the total number of revolutions made by electron in 1 second, that will be called as frequency. So frequency comes out to be the total distance traveled by electron in 1 second is called velocity of the electron divided by distance traveled in one revolution will be the circumference. It comes out to be the 2 pi r. So that's the formula for the frequency of revolution of electron around nucleus. So now let's talk about the next topic is the time period of revolution. So this was the frequency. The frequency is obviously the ratio of velocity and the circumference of the orbit. So its velocity divided by 2 pi r comes out to the frequency, the number of revolutions made by electron in 1 second. Now let's talk about the time period of revolution. Now we are talking about time period of revolution. So obviously this is the time required by electron, time required by electron to complete one revolution. The time required by electron to complete one revolution is called the time period of revolution or the time period of electron. So this time period, I'm representing this time period by the capital T. So the capital T will be equal to then distance traveled in one revolution, distance traveled in one revolution divided by total distance traveled in obviously it's a traveled by electron, is traveled in 1 second. So the time period is distance traveled by electron in one revolution divided by total distance traveled by electron in 1 second. This will give you the time for one revolution. So that comes out to be the time period of revolution by the electron. So it comes out to be, the capital T comes out to be, distance traveled in one revolution is the obviously circumference of orbit. It comes out to be 2 pi r divided by total distance traveled in 1 second comes out to the velocity of the electron. So this was the today's topic. Now time period is 2 pi r divided by velocity. On the other hand, we also know that frequency is equal to the velocity divided by 2 pi r. So that means the time period and frequency are inversely related to each other. That is, time period of revolution of electron will be equal to the 1 divided by frequency. So that is the final relation that we got between the frequency of revolution and the time period of revolution. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on the thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.